Yeah, children, I've shared my screen. Is it visible? And am I audible to all of you?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Very good. So, with respect to the chapter understanding quadrilaterals, I have to do two more sessions. One is the concluding session, and in the other session, you will have to take up a test on the chapter understanding quadrilaterals. So we have two more sessions for understanding quadrilaterals. But in the session today, I'm starting a new chapter, linear equations in one variable. All right. So let's first understand the difference between and let's first understand the difference between an expression and an equation. Okay. So when I write something like this, all right. So we call this an expression, an algebraic expression, because it's made up of variables and constants. The variable here is x, and the constants are 4 and 7. The variables and constants are connected by some or all mathematical operations. So here you see two mathematical operations, multiplication and subtraction. I'll repeat this. I said we'll first get the difference between an expression and an equation. So consider this example. In this example, you see this letter x, which is the variable, and you see these numbers 4 and 7, which are constants because they have a fixed value. 4 is 4, 7 is 7. 4 is a constant, 7 is a constant. X is the variable here because x can take any value. X can take any value. So x is the variable here. So in this example, you can see the variable x, you can see the constants 4 and 7, and these symbols 4, x, and 7, these are called symbols. Variables and constants are symbols. Variables and constants are symbols. They are symbols. Okay, so these symbols are connected by the mathematical operations multiplication and subtraction. 4x, 4x. So there's multiplication between 4 and x. 4x minus 7. Between 4x and 7, it is subtraction. So this is how we define an expression or an algebraic expression. See the definition now. Let's define an expression or what we call an algebraic expression. An algebraic expression, okay, an algebraic expression is a combination, of variables and constants, variables and constants connected by some or all mathematical operations. So when we say expression, we are talking about an algebraic expression, which is made up of variables and constants. And how are the variables and constants connected? They're connected by some mathematical operations or all mathematical operations. In some expressions, you will find all the mathematical operations. For example, say 4x, 4 by 7x minus, say like 5 y minus or say plus 7 by 3. So you can see division here 7 by 3, 7 by 3. Division, you can see addition, you can see subtraction, you can see multiplication. So you see all the 4 mathematical operations: addition, subtraction, multiplication, division. And here in this example, there are 2 variables, x and y. But for class 8, we are going to study expressions and equations in only one variable, x, y, or z. The variable can be any small letter from A to Z. We normally use variables as small letters from A to Z, any letter from A to Z in the lowercase. I said we will be dealing with expressions and equations in only one variable x. The variable can be any small letter of the English alphabet. X, Y, Z, something like that. Okay. So an algebraic expression is a combination of constants, variables and constants connected by some or all mathematical operations. Now we'll take up some examples of algebraic expressions. And so on. So that's about an expression or an algebraic expression. Then what's the difference between an expression and an equation? So when an algebraic expression, in an algebraic expression, you don't see the equal to sign, right? In an algebraic equation, you will see the equal to sign. It'll have the left-hand side and the right-hand side. For example, 4x minus 7 is equal to 5x plus 4. Now this one is not an algebraic expression. It is an algebraic equation. See, when do we use the term algebraic? Whenever you see constants and variables, it is algebraic. Whenever you see constants and variables connected by some or all mathematical operations. Okay, so whenever you see constants and variables put together using the mathematical operations, it is algebraic. It's an algebraic expression if you don't see the equal to sign. It's an algebraic equation if it has the equal to sign. If you can see the equal to sign, then it's an equation. Otherwise, it's an expression. So these are expressions. These are expressions, algebraic expressions, because they don't have the equal to sign. But this one is an algebraic equation because you can see the equal to sign here. Got that? All of you?
Yes, ma'am. Yes, ma'am.
Okay. Algebraic because we use the word algebraic because, algebraic because it's made up of constants and variables connected by some or all mathematical operations. In an expression, you will not find the equal to sign. In an equation, you will see the equal to sign. Is equal to. The sign or the symbol is equal to. Now, our study is limited or restricted to linear equations in only one variable. See, now see this example. Okay, this one is an example of an algebraic expression. Expression in 3 variables, A, B, and C. This one is an algebraic expression in 3 variables A, B, and C. So we'll not be studying such expressions or equations involving more than one variable. We'll be studying and solving equations in only one variable. Now, what is a linear equation? Why is it called a linear equation? Because the power of the variable will be 1. The power of the variable in the equation will be 1. Now, in this equation, 4x plus 5 is equal to 9. Okay. Now, this one is an equation because we can see the equal to sign. It's an equation. And it's an algebraic equation because it's made up of variables and constants. Now, it's a linear equation. It's an equation. You can call this a linear equation in specific, a linear equation, because the power of the variable involved is 1. The power of the variable involved is 1. Now, if you take this case, the power of the variable is 2. So this one is an equation, but it is not a linear equation. If it is a linear equation now we all understand. If you see the equal to sign, it's an equation. Linear means the power of the variable involved should be 1. If it is not 1, it is not linear. Now, in this example, this one is an equation, and in this equation, the power of the variable x is 1. So this one is a linear equation. In this example, the power of the variable x is 2. It's not 1, it's 2. So this one is not linear. It is not a linear equation. It's a quadratic equation. So we all understood?
Ma'am, can you explain that again?
Yeah, sure. So we understood what is. Yeah, I'll do it again. So algebraic meaning involving constants and variables. Algebraic meaning involving constants and variables. In an algebraic expression, you will not find the equal to sign. In an algebraic equation, you will see the equal to sign. And if the equation is a linear equation in one variable, that means the equation will have only one variable, say x, and it is linear because the power of the variable x is 1. The power of the variable x is 1. So for example, this is the variable because these are constants. They have a fixed value. This is the variable. The power is 1. The power of x is 1. So this one is an equation. It is a linear equation in one variable x. 2x minus 7 is equal to 4 is an equation. Yes. It is an equation in one variable. It is an equation in one variable. Yes, because there's only one variable x. Yes. And it is a linear equation. It is a linear equation in one variable x. It's a linear equation in one variable x. Yeah, because it's linear because the power of x is 1. You see the equal to sign, so it is an equation. There's only one variable x. And the power of x is 1. So this is an example of a linear equation in one variable x. Got that, Anirudh?
Yes, ma'am.
Okay. Now we're going to learn how to solve. We're going to learn how to solve linear equations in one variable x. Yeah, please write down. Write the name of the chapter.
Ma'am, Avnish has come, ma'am. Good evening, ma'am.
Yeah, good evening.
Ma'am, should we write this down? No?
Yeah, yeah.
Okay. Finished, ma'am.
Yeah.
Finished, ma'am.
Yeah.
Ma'am, can you go to the previous slide? This.
I just included examples for variables and constants. Please make a note of them.
Ma'am, for algebraic expression, you didn't give any example, ma'am.
Yeah, I'm going to write on the next slide.
Okay, ma'am. Completed. Done, ma'am. Completed, ma'am.
Yeah.
Finished, ma'am.
Yeah. Finish writing?
No, ma'am. No, ma'am. Done, ma'am.
Yeah. Okay. So this term linear is used when the highest power of the variable or variables used in the expression is 1. Now look at this example. Look at only the variable. So in this example, the variable is x. And what is the power of x? 1. So this is an example of a linear expression in one variable x. There's only one variable x. So one variable x, and it's a linear expression because the power of the variable is 1. Don't see these numbers 2 and 7. You should look at the power of the variable. That's all. Now in the next example, we see two variables x and y. We see two variables x and y. The power of x is 1. The power of y is also 1. See, we are not seeing the coefficient of x. The coefficient of x is 4. The coefficient of y is -5. We are not looking at the coefficients. We are looking at the powers. The power of x is 1. The power of y is 1. So both the variables x and y, they have the power 1. That means the highest power in this expression, the highest power of the variable is 1. So only when the highest power is 1, the expression can be called a linear expression. In the last example, you see three variables a, b, and f. But the powers of a, b, and f are all 1. So you can use this word linear because the power everywhere is 1. So the highest power is 1. So this one is an example of a linear expression in three variables, a, b, and f.
Ma'am, should we write this?
Yeah.
Okay, ma'am.
Now, tell me if 4x or say 14x minus 20, is this a linear expression? 14x minus 20?
Yes, ma'am. Yes, ma'am.
Okay. So it's an expression or it's an algebraic expression because it is made up of the variable x and constants 14 and 20. So you can see variable and constants. So it's an algebraic expression. And how many variables can you see? How many variables can you see?
One.
Only one. Only one variable x. And what's the power of x?
One.
One. So it is linear. The power of x is 1, so it's linear. So it's a linear expression in one variable x. Now, when you equate this to 0, it's called a linear equation. When you equate this to 0, it's called a linear equation. A linear expression, when equated to 0, is called a linear equation. Now, is this a linear expression? X plus y minus 3. Is it a linear expression?
Yes, ma'am.
Yeah, it is a linear expression. It's an expression because we see variables and the constant 3 here. So it's made up of variables and constants. So it's an expression. It's an algebraic expression. And the variables are x and y. The power of x is 1. The power of y is also 1. So the highest power is 1. The highest power of the variables involved is 1. So you can use the term linear. X is raised to the power 1, y is also raised to the power 1. So the highest power of the variables is 1. So you can use the term linear. So x plus y minus 3 is an example of an expression, or you can say an algebraic expression. Expression, algebraic expression, both are the same. So this is an example of an expression in two variables x and y. And it is a linear expression because the power, the highest power of the variables is 1. So it's a linear expression. So this is an example of a linear expression in two variables x and y. Now, when you equate this to 0, it's called a linear equation. When you equate this to 0, this is a linear equation in two variables, x and y. Done writing, children?
No, ma'am.
Okay.
Finished, ma'am.
Yeah. Okay. So now I need to tell you about the standard form of a linear expression and a linear equation. Let's understand them. See, I'll just take an example. It's easy to remember the standard forms. Now let's just take an example. Say something like, 6x plus 5. Now this is a linear expression in one variable x. Now you have to write the standard form. This is a specific example, but you have to give a generalized version. You'll have to give a general expression. This is a specific one. 6x plus 5 is a specific example. But when we say standard form, you have to write a generalized one. So for this for this 6, we'll use the letter A. Now x is the variable, so x is x. The sign can be plus or minus, but in general we take as plus. It can be minus also. And this is B. So this is the standard form, AX plus B. See now, if it is 6x minus 5, but 6x minus 5, then if you compare this with the standard form, ax plus b, then a is 6 and b will be minus 5. Because 6x plus minus 5 it is. 6x plus minus 5. Ax plus b. A is 6 and b is minus 5. So another example, say minus 3x minus 7. Okay, so you can treat this as minus 3x plus minus 7. So the standard form is, this is a specific example. So the generalized one will be, for minus 3, we'll say a. For minus 3, we'll say a. X is the variable. Plus, for minus 7, we'll say b. So ax plus b. So ax plus b is the standard form of a linear expression in one variable x. Now we have some conditions. A and b can be any real number, any real value. But a should not be 0 because, look at this example. If I say 0x plus 7, 0x is 0. That means this is only 7. Then how do you call it a linear expression in one variable x? There is no variable at all, no? If a is 0, see here, 0x plus 7, for example. When you compare this with ax plus b, a is 0, a is 0. Now, if a is 0, what happens? 0x is 0. That means the x term is not there. So this is only 7. 0x plus 7 is only 7. So there is no variable x. And if there is no variable x, only if there is x, the power is 1. So you call it linear. Now the variable itself is not there. So you cannot call it a linear expression. There is no variable at all. That's why the condition A and B can be any real value, but A should not be 0. B can be 0. Like 5x. This is an example. 5x is an example of a linear expression in one variable x. See, we can use the term, for this example 5x, we can use the term linear because the power of x is 1. The power of x is 1. So you can say linear because the power of the variable is 1. And you can call this an expression because, yeah, 5x, it's made up of constants and variables. So it's an expression. So it is linear because the power of x is 1. And it's an expression because it's made up of constants and variables. And you can see one variable x. So this 5x is an example of a linear expression in one variable x. So now this is like 5x plus 0, ax plus b. So a is 5 and b is 0. So b can be 0. A should not be 0. Because if a is 0, then the x term itself will go missing. And if the x term is not there, then how do you call it linear? That's why the condition a and b can be any real value, but a should not be 0. B can be 0. A should not be 0. So ax plus b. Again, I'm giving you an example. Say minus 7x plus 6. So this is of the form ax plus b. This is a, this is x plus, and this is b, ax plus b. So ax plus b is a standard form of a linear expression in one variable x. Condition a and b can be any real value, but the coefficient of x, which is a, should not be 0. And the standard form of a linear equation in one variable x linear equation in one variable x is ax plus b is equal to 0. Because equation means equated to 0. Equate the linear expression to 0. This is the linear expression in one variable x. If you equate this to 0, it's called a linear equation. So this is a standard form of a linear equation in one variable x. Same conditions. A and b, any real value, a should not be 0. Yeah, how do you solve this? So this is the linear equation in one variable x. So this is given to us. How do you solve this?
Ma'am, we should bring +5 to the other side.
Correct. So 4x is equal to 9 minus 5. Plus 5 becomes minus 5 on the other side. Next.
Bringing by 4 divided by 4 to the other side, we get multiplication. Sorry, bringing multiplying. So x 4 by 4 is equal to 1. X is equal to 1.
Correct. Correct. So what you have to do is, you'll have to first transpose plus 5. So plus 5 on the other side becomes minus 5. So 4x is equal to 9 minus 5. So 4x is equal to 4. Plus 5 becomes minus 5 on the other side. Now here 4 into x. 4 and x, they're connected by the multiplication sign. So this 4 will come for division to the other side. X is equal to 4 by 4. X is equal to 1. Yeah, write down.
Finished, ma'am.
So you'll have to have the variables on one side and the constants on the other side. Now there are 4 terms here. 1, 2, 3, 4 terms. 2 terms are x terms and the other 2 terms are constants. 2 terms are x terms. So have the x terms on one side and have
then
the
the
constants
constant.
on the other side. So this 3x, write it as it is. Now this x which is on the right hand side should be transposed. So it'll come to the left hand side. This x will become minus x here is equal to this 5 which is here on the right hand side, write it as it is. This minus 5 from the left hand side travels to the right hand side. So minus 5, when it goes to the other side, it becomes plus 5.
2x is equal to 10.
See, we're just trying to gather the x terms on one side and the constants on the other side. Whoever travels will take the opposite operation. If it's plus, it will become minus. If it's multiplication, it will go for division. If it's division, it will go for multiplication. If it is subtraction, it becomes addition. Whichever term is transposed, that goes to the other side, Transposing meaning taking it to the other side. When you take it to the other side, the operation is reversed. Addition and subtraction are opposite operations. Multiplication and division are opposite operations. With addition, it becomes subtraction. If it is subtraction, it becomes addition. If it's multiplication, it becomes division. If it's division, it becomes multiplication. If you're writing the term wherever it is on the same side, then there'll be no change. So this 3x, it's on the left-hand side. We write it there only on the left-hand side. So no change. This x from the right-hand side comes to the left-hand side. So it's plus x here. It will become minus x. Is equal to this 5 which is here as it is. This 5 should travel. It should go to the right-hand side. Minus 5. On the other side, plus 5. So 3x minus x, 2x is equal to 5 plus 5, 10. Now here 2 and x, they're connected by the multiplication sign. 2 into x. So x is equal to 10 divided by 2. X is equal to 5.
Finish, ma'am.
Yeah.
Done, ma'am.
Yeah. What about Harini and Srijit?
Completed, ma'am.
Okay. Okay. I always write the question first. Now listen to me carefully. How many, answer my questions. In this equation, how many terms do you see? How many terms are there? How many terms on the left?
3.
Okay. How many terms on the left hand side?
2.
How many terms on the right hand side?
1. 3.
How many
One.
x terms?
2.
2 x terms are there. 2 x terms. You must gather them. So let this x which is on the left hand side stay there. So this 2x will come to the left hand side. Or 2x is transposed. So it will become minus 2x, correct?
Ma'am,
And this plus,
okay.
and this plus 3 by 2, which is on the left hand side, is transposed, comes to the other side, right hand side. Look at minus 3 by 2. So in this step, what we have done is we have collected the variables. The x terms, not the variables. There's only one variable x. We have collected the x terms. 2 terms have x in them. So we have collected the x terms on the left hand side. And we have the constant minus 3 by 2 on the right hand side. Now x minus 2x is minus x is equal to minus 3 by 2. Now you can cancel the minus sign on both the sides. So the value of x is equal to 3 by 2. Any questions? Please ask me.
Ma'am. Done, ma'am. No doubts. No doubts.
Okay. Now in this question, how many terms do you see on the right hand side and the left hand side?
Ma'am, right hand side 1, left hand side 1, 3. 1, ma'am. Ma'am, 3, ma'am, because 1, 3x, 2x. Then 2x divided by 3x plus 1. No, then 1 is also a term. Oh, 3x plus 1 is also a term. Ma'am, actually 2. 3x plus 1 is a 3. Ma'am, there are 2 terms.
Correct. So there's only one term. This is one term on the left hand side. This is one term on the right hand side. See, now here also there was 2x. No, you didn't say 2 terms. 2x is only one term. Terms are separated by a plus or a minus sign. See, here we had 2x. No, you said it's only one term, and that's right. This is only one term, 2x. Similarly, this is only one term. 2x by 3x plus 1 is one term. Terms are separated by a plus or a minus sign. So now here on the left hand side, you have one term. On the right hand side, you have only one term. In the given question or in the given equation, on the left hand side, we have one term. On the right hand side, we have one term. Now, the left hand side and right hand side, they are completely simplified. We can't do anything further with this one, 2x by 3x plus 1. What can you do with that? Nothing. Minus 3, nothing. It's completely simplified. There's only one term on the left hand side and one term on the right hand side, and no further simplification is possible in the left hand side and the right hand side. So at this point, when it looks like this, what you have to do is cross multiply. You will have to cross multiply. How to cross multiply? See, like this, like this. 2x into, there's nothing here, no? So like 1. So just write 2x. 2x is equal to, now multiply these two. How do you write that? Minus 3 into 3x plus 1, like this. Multiply. Multiply this with this. That is the numerator here with the denominator on the opposite side, and the denominator here with the numerator on the opposite side. Cross multiply. So 2x is equal to minus 3 into 3x plus 1. See, minus 3 into 3x plus 1. Is this understood?
Yes, ma'am.
Next, 2x as it is equal to, now how do we multiply? Multiply this minus 3 with every term inside the bracket. Multiply minus 3 with every term inside the bracket. Inside the bracket, there are 2 terms. So minus 3 into 3x. Minus 3 into 3x, minus 9x.
Minus 3 into 1.
Minus 3 into plus 1. Minus into plus, see, minus 3 into plus 1. Minus into plus minus, 3 into 1, 3. Whenever you multiply, whenever we multiply two terms, you should multiply their signs and then multiply the numbers and the variables. Multiply the signs and write them first. You're multiplying two terms. No, the two terms will have their own signs. Multiply the signs and write the answer first. And then multiply the numbers and the variables. So this is the next step. Now you see this equation has three terms now. It has two x terms. 2x minus 9x. There are two x terms, but they're on the opposite sides. You must have them on the same side. So write this 2x. See, look at this equation. There are three terms, 2x, 2x, minus 9x, and minus 3. It's okay. You can tell them without the signs also. So 2x, 9x, and 3. You should identify how many terms are there. There are three terms. And how many x terms? Two x terms. Now the x terms should be on the same side. So transpose. The x terms, have them on one side. So write 2x as it is on the left hand side, minus 9x. It's on the right hand side. So it will travel to the left hand side. So minus 9x will become plus 9x. Minus 9x is on the right hand side. When you transpose, it goes to the left hand side. So minus 9x will become plus 9x. And that minus 3, it's on the same side. You're writing it on the right hand side only. So don't change the sign. If you take a term from one side to the other side, only then you should, take the opposite operation. When a term moves from one side to the other side, then the operation will be reversed. If you're writing it on the same side, there'll be no change. So minus 3, see, it's on the right hand side. You're writing, see, it's after the equal to sign. Here also you're writing it after the equal to sign. So minus 3 is minus 3. Now 2x plus 9x is 11x is equal to minus 3. X is equal to minus 3 by 11. Finished?
Yes. Done, ma'am. Done, ma'am. Completed, ma'am.
Very good. Okay, I think we just finished this. So again, in this question, we have only one term on the left hand side, one term on the right hand side. And both the sides are completely simplified. You cannot do anything with the left hand side or the right hand side. LHS is completely simplified. 3x plus 5 by 2x plus 7. You can't do anything further with that. And on the right hand side, you have 5. Nothing you can do with that. At this stage, you can cross multiply. If some simplification is possible on the left hand side or right hand side, then you should not cross multiply. Cross multiplication should be done only when there is only one term on the LHS, one term on the RHS, and the terms are completely simplified. Okay, so here cross multiply. So 3x plus 5, 3x plus 5 Into 1. It's like into 1. There's nothing. It's 5 by 1. No. 5 means what? 5 by 1. What is 5? 5 means 5 by 1. That's like you're multiplying 3x plus 5 into 1. So that's going to be 3x plus 5 only. So just write 3x plus 5 is equal to 5 into
3x plus
2x plus 7. Like this. 5 into 2x plus 7 like this. Why should you write 2x plus 7 in a bracket? Because you cannot write 5 into 2x plus 7 like this. 5 into 2x plus 7 like this. Because 5 has to be multiplied with 2x and 7. 5 should be multiplied with 2x and 7. That's why we write 5 and in brackets 2x plus 7. Is this step understood, all of you?
Yes, ma'am.
Cross multiplying 3x plus 5 into 1 is 3x plus 5 is equal to 5 into 2x plus 7 like this. Now 3x plus 5 as it is equal to, open the bracket, 5 into 2x. So how do you multiply 5 into 2x? 5 into 2, 10, x, 10x. Now multiply 5 and 7. 5 into 7. What's the sign carried by 5? Plus. And 7 plus. So plus into plus, plus 5 into 7, 35. Multiply the signs and then multiply the numbers 5 and 7. So now we see that we have 4 terms. 4 terms, 2 terms on the left hand side, 2 terms on the right hand side. There are 2 x terms. So gather the x terms. 3x is on the right, 3x is on the left hand side, write it there. 10x from the RHS goes to the LHS. So it will become minus 10x. Whoever travels, they'll take the opposite sign. Is equal to 35. 35 is after the equal to sign. Where is 35? It's after the equal to sign. There only we are writing after the equal to sign. So 35 is 35. Now who has to travel? Plus 5 from the left hand side has to come to the right hand side. Plus 5 is before the equal to sign. It should come to the plus 5 is before the equal to sign. It should come after the equal to sign. So it will become minus 5. Now 3x minus 10x is minus 7x is equal to 30. X is equal to 30 by, see here, minus 7 into x it is. So its multiplication will come for division as minus 7 only. It will not become plus 7 because multiplication becomes division. That's all. Minus 7 will come down as minus 7. So x is equal to minus 30 by 7. You can take the minus sign to the numerator or you can put it in the middle. So x is equal to minus 4, 2 by 7.
Ma'am?
Yeah.
Should we write like the whole number, ma'am, like minus 4, 2 by 7?
Yeah, if it is an improper fraction, you should convert it to a mixed fraction.
Okay, ma'am.
Okay.
Finished, ma'am.
Okay.
Done, ma'am.
Yeah. Yeah, try these questions. I'll come back in 5 minutes. Please work these. Yeah. So how do we proceed with the seventh one?
Ma'am, 1 by 1. Ma'am, 2y plus, ma'am.
So it's like 1 by 1, right? So,
Yes, ma'am.
yeah. So 2y plus 5 into 1 is going to be the same thing. 2y
Yeah.
plus 5. 2y plus 5 into 1. So just write 2y plus 5 is equal to
2y minus 5 y plus 4.
y plus 4. Y plus 4. 2y plus 5. 2y plus 5 into 1 is 2y plus 5. And y plus 4 into 1 is y plus 4.
Then 2y minus y is equal to minus 5 plus 4. Y is equal to minus 1. Ma'am, but when we like do 2 into minus 1, we'll get minus 1 only, ma'am. So we can prove that the answer is correct like that.
Or when you substitute y as
Yeah.
minus 1, you're saying?
Yeah, we can prove it
You
like
need to
that.
be clear. You're so fast. You need to talk slowly and clearly.
Okay, sorry.
Yeah. When you substitute in the question, on the left hand side, when you substitute minus 1 in place of y, okay, so what do you get? 2 into minus 1 plus 5 by minus 1 plus 4. That's what you're trying to say, right?
Yeah.
So this is minus 2 plus 5, 3 by 4 minus 1, 3. 3 by 3 is 1. And that's what we have on the right hand side.
Yes, ma'am.
Okay. Yeah, Srijit, can you tell me this one? Srijit. Harini?
Ma'am.
Yeah.
Ma'am, ma'am, below 8 we should have to put 1, ma'am. 8 by 1, ma'am.
Very good.
Next step is 3x plus 2 equal
Correct.
to 2x minus 3.
3x plus 2 into 1 is 3x plus 2. 2x minus 3
Yes.
into 8.
Yes, ma'am.
8 into
1.
2x plus 3. 2x minus 3.
Yes, ma'am.
Yeah. Next step.
3x plus 3x plus 2 equal to
What is 8 into 2x?
16, ma'am.
16.
16x minus 24, ma'am.
Correct.
Next
Next.
step is 3x minus 16x
Very good.
equal to 24 minus 2, ma'am.
No. Where is minus 24? Is it on the right hand side or left hand side? Minus 24. Is it after the equal to sign or before the equal to sign?
After the equal to sign, ma'am.
Yeah, so you're writing it there itself, right?
Yes, ma'am.
So minus 24. You said only 24. Minus 24.
Yes.
And then which one is traveling to the right hand side?
2, ma'am.
Plus
2.
2 is traveling. So it comes as?
Minus 2.
Yeah. So plus 2 has to come to the other side. So it will come as minus 2.
Yes,
Yeah,
ma'am.
next. 3x minus 16x.
12x, ma'am.
No.
No. 13x, ma'am.
Correct. Sign greater number.
Minus 13x, ma'am.
Correct. Is equal to
Equal to 26, ma'am.
see, you must always say with the sign. If it is plus 26, fine. If it is minus 26, you'll have to mention minus.
Minus 26, ma'am.
Okay. Now the minus on either sides will get cancelled.
Yes,
So
ma'am.
what's the value of x? X is equal to
26 by 13, ma'am.
correct, which is
Uh,
2.
Ma'am, I need to cancel it. Oh, yes, ma'am.
Yeah, 13 twos are 26. Very good, Harini.
Yes, ma'am. Thank you, ma'am.
Yeah, very good. Anirudh, next one.
Ma'am, 5z minus 3 by 2z is equal to 8, 9, ma'am. 5z minus 3 is equal to 8 by 9 into 2z. Cross multiplication.
No, when you cross multiply, it's like this. 9 into 5 is equal
9
to
into 5. 9 into 5z minus 3 is equal to 2z. 8 into 2z.
8 into 2z. Yeah. Or 2z into 8.
40z
Any order
minus
you can write. You can write 2z into
okay.
8 or 8 into 2z.
40z minus 27 is equal to
Not 40. 9
8.
5s are 40.
45.
9 3s
45z minus 27.
is equal to
8 into 2z.
16z.
16z, okay, ma'am. Ma'am, and then we should bring 45z to other side. We
No.
get 60.
Bring 16z to the left hand side. We'll have the variable terms on the left hand side.
45z, 45z minus 16z.
Is equal to, take the number to the other side.
27.
Minus 27 will become plus 27. Minus
Yes, ma'am.
27 is on the left hand side. So on the right hand side, it will become plus 27. Next.
Ma'am, next. Ma'am, 1 minute, ma'am. 15. Ma'am, 29z. 29z is equal to 27.
29z is equal to
27. Z is
27. So z
equal
is
to
equal to
27 by 29. And then we should divide it.
no, you can leave it like this because it's a proper fraction.
Oh, yeah, ma'am.
Yeah, very good. Very good, Anirudh. Yeah, please
Okay.
check your answers, all of you.
Ma'am, I got everything right.
Very good.
I too got everything correct, ma'am.
Very good.
Ma'am, I got the last sum. I didn't do it, ma'am. You came, ma'am.
Oh, I'm so sorry. Okay. I didn't check. Actually, I thought, I just assumed all of you must have finished. I'm sorry, I didn't check. Okay.
Okay.
Done, all of you?
Yes, ma'am.
Yeah, try these. Srijit, you're not there, Srijit. Okay. Who wants to share this answer?
Ma'am, me.
Yeah, tell me.
Yes, ma'am. क्या क्वेश्चन है ये 10th मैम 25 y minus 15 is equal to 4y
I want the
plus 2.
steps. I want the steps. I want the step.
You already cross multiplied. You have to tell bro. Okay. Ma'am, 5y minus 3. Ma'am, 5y. Ma'am, 5
No, no,
bracket.
I'll just
5
pass it to. No, I'll just pass it to Avinish. Avinish, tell me.
Ma'am, we have to do cross multiplication, ma'am. 5y
Correct.
into 5, 5y minus 3 into 5, ma'am. So 25.
So it'll be
25.
5. How do you write that? 5 into 5y minus 3
5y minus 3
is equal to
2 bracket 2y plus 4 1.
yeah.
Ma'am, can I say, ma'am? I'm sorry.
Yeah, continue.
Yes, ma'am. 25y minus 15 is equal to 4y plus 2. 25y minus 4y is equal to 15 plus 2. 21y is equal to 17. Y is equal to 17 by 21.
Very good, Ramneet. Very good. Okay, who wants to share the answer with the next one?
Ma'am, can I do again?
No, no. You're still working on it, children? Okay, so nobody is ready to share the answer for the 11th one?
Ma'am, can I say?
Yeah. No, somebody else. Navneet, you tried the earlier one. I heard another
No,
voice.
ma'am.
Who's that?
Ma'am, Anirudh.
Yeah, tell me. Anirudh.
Ma'am, 3x minus 8 into 28. Ma'am, so 28 into 3x minus 8 is equal
Yeah.
to 9 into 4x plus 4. 84x minus 224 is equal to 36x plus 36. 84x minus 224 is equal to 36x plus 36.
Okay.
48x is equal to 260.
No.
Ma'am,
Transpose.
I missed a step, ma'am. I missed a step. Wait, ma'am.
Yeah.
84x, my 84x minus 36x is equal to 224 plus 36, and then 48x is equal to 260. X is equal to 260 by 48, which is 65 by 12. 65 by 12.
60?
5 by 12.
Okay,
130
so in the
times
tables of
124.
4. In the tables of 4. 4 6 are
Ma'am,
24. 2 remains. 4 5s are. And then 4 12 are 65 by 12. As a mixed fraction?
yeah. Ma'am, I didn't do that, ma'am. Wait, ma'am.
Yeah.
Ma'am, 5, 6, 5, 5 by 12.
Correct. 5 by 12.
Ma'am, we can just leave it like that, no, like 65 by 12 also. No need to convert it to 65 by 12, no? Or is it mandatory?
Yeah, improper fractions must be written as mixed fractions.
Okay, ma'am. I didn't write that. I just wrote 65 by 12.
Always change improper fractions to mixed fractions. Yeah, Avanish, try this one.
Ma'am, 1 second, ma'am.
Yeah.
Ma'am,
Yeah.
8. Ma'am,
Yeah.
8 in bracket 1 minus 9y is equal to 5 in bracket 19 minus 3y.
Very good.
Ma'am, 8 next step multiplication. Ma'am, 8 minus 72y is equal to 95 minus 3y. Sorry, minus 15y.
Correct.
Then we have to shift 15y to this side, ma'am. 15y minus 70.
No, first you write, okay, you want to write 15y first. Okay, fine. You write the term which is already there. What is already there? Minus 72y is already there. No, but anyways, it's fine. Yeah, you can also write, 15y first. So minus 72y, which is already on the left-hand side, plus 15y, yeah, is equal to?
Equal to 95 minus 8.
Yeah. So already there is 95 on the right-hand side. Write that, and then 8 goes to the right-hand side as minus 8. Yeah, next. Different signs, subtract.
Subtraction. 50 minus 57y
Correct. Is equal to?
is equal to 87.
Correct. So y is equal to?
Y is equal to 87 minus 3 by 87 by 7 minus 75.
Minus 57.
Sorry, minus 57.
Yeah.
Is equal to minus 87 by 87.
Correct. I'll just. Okay, next.
Ma'am, can we cancel it?
Yes, you can.
Ma'am, can we cancel it in 3 times?
Correct. Yeah, so 3 how many times? 87.
Just a second. 29 times. Ma'am.
Yeah. 3, 29 times 87, and 3?
19 times.
19 times. So y is equal to minus, write that as a mixed fraction. 29 by 19 as a mixed fraction. Yes, as a mixed fraction. 19 and 29. 19 ones are 19. 10 is a remainder. So
110 by 90. Ma'am, that's it? Or we have more questions?
finish writing, all of you?
Yes, ma'am. Yes, ma'am. Ma'am, no, ma'am.
Yes, ma'am.
1 minute. 1 minute. Finish, ma'am.
Okay. All of you?
Yes, ma'am. Yes, ma'am.
All right. Yeah. With this, we'll wind up the session for today. Let's work this together. The first step, cross multiply. So 5 into 0.4z minus 3 is equal to minus 7 into 1.5z plus 9. Now we need to multiply 5 and 0.4. What is 5 into 0.4? Tell me. What is 5 fours are?
2.8. Ma'am, 2.8. 2.8. Ma'am, 0.20. अबे नहीं यार.
What is 5 fours are?
5 fours are 20.
And then in the
Ma'am,
product,
2. Ma'am, 2.
in the product, you
0. 2.
you need to place a decimal point.
2.0.
Yeah, between 2 and 0, 2.0.
And minus 15.
So 5 into 0.4 is 2.0.
Z.
Which is nothing but 2.
2.0 Z minus 15 is equal to
2.0 is nothing but 2. So you can directly write 2. You don't have to write 2.0. 2z minus 15 is equal to, what is 15 into 7?
15 into 7. 15 into 7. Ma'am, 105.
Now where do you place the decimal point?
Yes,
Between?
ma'am, we can. Ma'am, we can do like between 0 and 5, ma'am. Now we can just do 7 plus 3.5. 10.5 will come as the answer. Simple.
Yeah, that you can do. Yes.
Yes.
Now, where do you place the decimal point? Between?
Between 10 and 5.
0 and 5.
Okay. 0 and 5. Yeah.
So be minus 10.5 Z minus into plus minus.
Minus.
7 9 the 63. See, I'll just show the multiplication again. See, you need to multiply minus 7 and 1.5 Z. Then you need to multiply minus 7 and plus 9. You need to multiply minus 7 and 1.5 Z, which is plus 1.5 Z. And then you need to multiply minus 7 and plus 9. So minus into plus minus 10.5 Z. Here minus into plus minus 7 9 the 63.
Yes. Mama, I finished the answer only.
Now transpose.
Yes, ma'am. Ma'am, can I say?
Yeah.
Ma'am, 2Z plus 10.5Z is equal to minus 63 plus 15. So, 12.5Z is equal to minus 48. Z is equal to minus 48 by 12.5.
Yeah. Then after this?
Simplify.
Yeah.
Z is equal to minus 48.
Yeah.
0.5. 6.25 and 24.
No, I want you to shift the decimal point.
Ma'am, into 10.
Correct. Who said that? Correct. Very good. Multiply the numerator and denominator by 10 in order to get rid of the decimal point. So you can just do that in your mind, or you can show that here into 10 by 10.
Ma'am, minus 480 by 125.
Now you should simplify.
Yes, ma'am. Pi table.
525 times 5 9s are 45. 3 remains. 5 6 are 30.
Ma'am, minus 96. Yes, ma'am.
Minus 96 by 25.
Yeah, that.
It's an improper fraction. You cannot simplify this any further. 96 by 25 cannot be simplified further. So write it as a mixed fraction.
Ma'am, 3. Ma'am, 321 by 25. 3. Ma'am, 321 by 25. Minus 3. Yes.
Correct.
Ma'am, I did it in my mind, ma'am. I did not calculate it.
Very good.
Then I too did it. You wrote, I saw you by the back of the page. Yes, ma'am. Completed.
Done, children?
Yes, ma'am.
Finished? Harini, Navneet?
Yes, ma'am. Completed everything.
Avinish, Anirudh, Srijit?
Ma'am.
Harini completed?
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you, children.